Okay, hi everyone. I hope I find you well. I'm going to illustrate how variation of parameters works to solve some second order ordinary differential equation. So I'm going to illustrate this ODE y prime prime plus 3y prime plus 2y is equal to 1 over 1 plus e to the power of x. So what we do from this given expression, we start off by assuming a homogeneous ODE. In other words, we start off by trying to find the complementary solution of the homogeneous ODE 3y prime plus 2y equal to 0. Alright? And then the auxiliary, some prefer to call it the characteristic, the auxiliary equation for this homogeneous ODE, it becomes r squared for this one plus 3r plus 2 is equal to 0. So factorizing this characteristic equation or auxiliary equation gives you, we are looking for two numbers, which when added gives you a 3, when multiplied gives you a 2. What are those two numbers? It's 1 and 2 from your metric knowledge. Okay, so having established so now from here you can now establish the roots of this auxiliary equation. So this implies that r is equal to -1 or -2. Now, so we can write the complementary solution for this homogeneous ODE as C1 e to the -x for this one, and the second piece says e to the -2x. Now, having found the complementary solution, therefore, we can now tell the nature of a particular solution of this problem. So the particular solution will take this form u1 y1 plus u2 y2. Basically what you're doing here, you're just matching. Where there's a C1 you replace with u1, where there's a C2 you replace with the u2, like that. So from here you identify that your y1 is none other than e to the -x, and your y2 is none other than e to the -2x. Alright? Having identified these two guys, now we are now going to work out what u1 and u2 are, and then the y1, y2, we know them already. We picked them from the complementary solution. So how do we find the u1 and u2? This is how we do it. So we know that u1 prime is given by -y2 multiplied by a given f of x over the modulus of the Wronskian. And also u2 prime is given by -y1 multiplied by f of x, everything divided by the modulus of the Wronskian. Alright? So if let's start off with this one so that we determine what is u1. So as you can see, ladies and gentlemen, f of x is none other than the function that exists on the right hand side of your given original ODE, but we want to determine what the Wronskian is. So but the Wronskian is given by the determinant of y1, y2 there, y1 prime, y2 prime. Okay? So if we replace now what is y1 from the previous state, we can see that y1 is e to the -x and y2 is e to the -2x. All Alright, and the derivative of e to the minus x is none other than minus e to the minus x. Alright, and that of course becomes minus 2e to the minus 2x. Alright, so if you find the determinant, it's easy. It's this times that. You have minus 2e to the power. So multiplying, we add the powers. So it becomes minus 3x. Then minus. This times that, because of this minus, it ends up saying plus. It becomes e to the power minus 3x. So simplifying these guys, you end up with e to the power of minus 3x. But remember, it's negative here. It's negative, okay? Because this is e minus that. So look at this. The formula for finding u1 and u2 requires that we plug in a positive, the modulus. We will ignore that negative of the Wronskian. So let's calculate what is u1 prime. u1 prime is minus y2. y2 is this function. So we say minus e to the power of minus 2x. That multiplied by the function f of x is 1 over 1 plus e to the x, close that bracket. Everything divided by the modulus of the Wronskian, which is e to the minus 3x. Be careful. If you take the modulus of that, it's only this sign that gets to be positive. Then the power remains negative like that. It's not affected by the modulus sign. So now we're going to simplify things out. So this negative, when you consider taking this denominator to the top, then the powers will subtract, and then the negative sign will appear, and you end up with minus. So you end up with e to the x multiplying this guy. So it's e to the x over 1 plus e to the x. So this is a derivative of u giving rise to that. So we want to reverse so that we extract u1. So u1, so this implies that u1 is equal to the negative. So if I want to reverse differentiation, I integrate. So this negative integral of e to the x over 1 plus e to the x dx. So as you can see, guys, if I differentiate the denominator, I get the numerator. So we apply that rule of integration, which says this will transform to negative ln of modulus 1 plus e to the x. I found u1. In the same manner, I should work out what u2 is. So u2 is equal to, we are now using that formula. Remember, oh sorry, that's my bad. The u1 should be the one with a negative, but u2 doesn't have a negative, and it makes use of y1. So let's pick y1 then. It's going to be e to the minus x. That multiplied to f of x, which is 1 over 1 plus e to the x. This is the function f of x. Everything divided by the modulus of that, which is e to the negative 3x. Okay, let's try to simplify this. This goes on top, and negative 3x becomes positive. 3x minus x is e to the 2x. So I'll end up with e to the 2x over 1 plus e to the power of x. But guys, as you can see, I can't integrate this thing at the well, you can well, yeah. If you yeah, you can. Then okay, there could be another way, but the approach that I took that I see quite handy is this. I noticed that this power that sits on top is bigger than the numerator, and therefore this quantity on top, if the numerator is bigger than the denominator, we end up with an improper fraction. It's an improper fraction. So first of all, I should try to simplify that, split it and get a mixed fraction, and then I can now integrate the mixed fraction. So let's do that. So for me to get a mixed fraction, I'll just divide, and I'll employ long division to divide into e to the power of 2x. E to the x into this guy is, I'll end up with exactly e to the x, such that if you are dividing, separate the powers, that's why I got that. So you say this times that, you end up with e to the 2x. Then e times that, you get e to the x. And then I subtract to eliminate this minus this 0, then I'll remain with e to the... Okay. So as you can see, this is bigger than that. I can't divide anymore. So therefore, I can happily say e to the power of 2x over 1 plus e to the x is equal to, I got that whole figure, that whole number. This is the remainder over the divisor. Okay, so this is another way of writing that. So now I can integrate, therefore, so this is u prime, sorry. Now I'm going to integrate to get u2. So I'm going to integrate this whole thing minus e to the x over e to the power of x plus 1, everything dx. Let's do that. So u2 is equal to, integral of this with respect to x doesn't change, minus integration of this. Look at this, it's exactly the same as that. So the derivative of the bottom function gives me the numerator, so I can happily say this is the natural logarithm of the denominator. Okay, now that I have u1, u2, y1, y2, I can write the overall solution. The general solution now will be equal to y is equal to, you remember it should be, I should have the complementary solution here. It's c1 e to the power minus x plus c2 e to the power minus 2x. Now I want to include this particular solution now. Remember, it was u1, y1. So u1 is that times y1. y1 was e to the power minus x. So if I say this, so it becomes e to the power minus x ln 1 plus e to the power of x. Alright? So that's u1, y1. Alright? And okay, u1, y1. Okay. So I want to write this other piece which says u2, y2. So this is my u2 and y2 was that. So if I say, so this is going to be plus, I'll have e to the power of minus 2x, open bracket, this is y2 times u2. It's going to be e to the x minus ln modulus of, it doesn't matter, okay, modulus of that, close that bracket. All right. So this becomes the solution of our ODE. All right. This is the general solution of the given ODE. Remember, the general solution should be a combination of the complementary solution plus a particular solution, which is exactly what we have in this expression, where you can simplify further by grouping stuff together, which is not that difficult. But if you reach at this stage, then you get the question correct and get all the marks. All the best, and I hope to see you soon in my next videos. Bye for now.